Hello guys, welcome to my channel once again. Today we are going to discuss about gas turbines. So here we will be discussing about different sorts of gas turbines, which type of gas turbine is suitable for aircraft, and how this power is generated with the help of gas turbines. This is what we are going to discuss. So in our contents we will be having introduction, history, operation, advantages and disadvantages of gas turbines, future requirements, emission in gas turbines, need for future gas turbines. These are what we are going to discuss, and then we'll be having what is gas turbine. First of in order to go further, we'll need to know what are turbines. Turbines are machines to extract fluid power from fluid flows. So whenever there is a flow of fluids, that fluid flow power, we are going to convert it into our required power. So here if we classify these turbines into further, then we will be having four types of turbines. One is steam turbines, water turbines, wind turbines, gas turbines. Right, steam turbines will be using hot gases, and water turbine will be using water. These will be placed under the water. Because of flow of waters, there will be a rotation in turbine blades, and then whenever we move with wind turbines, then wind turbines will be using wind. Free flow of wind will be used, and in gas turbines we are going to generate gases, that is high temperature gases we are going to generate in it, and these high temperature gases we are going to use it for power generation. So here if we go with the gas turbines, these are used mainly in an aircraft engine in order to generate power. So these these gas turbines can generate high pressure, high temperature gases. Because of the flow of these high pressure and high temperature gases, we will be able to extract the amount of energy, and then generated inside the engine. That is high pressure and high temperature gases, and these gases expands through a specially designed turbine. For the expansion process, we are going to use this turbine. So if we go with the history, it is invented in 1930 by Frank Whitley and patent in 1934. This is first used for aircraft propulsion in 1942 on ME 262 by German during Second World War. The gas turbines came into an existence. Before that, will be used to have piston engines, and then currently most of aircrafts and ships use gas turbine engines. These are used for power generation. Manufacturers, most common manufacturers are General Electric, Pratt & Whitney, and SNECMA, Rolls-Royce, Honeywell, Siemens, Westinghouse, Alstom. Then we'll be moving with further thing, that is how these gas generators are operated. So here we'll be having 5 sections. One is intake, compressor, combustor, turbine, and then we'll be having nozzle. That is a free turbine, we can call it as. So here in intake, the intake will slow down the air. That is, incoming air will be slowed down by the intake, and then removes distortions. Then it will pass the air which we have taken through the inlet will be passed to compressor, where dynamically compresses the air. Okay, in compressor will be dynamically compressing the air. Then these compressed air which are having reduced velocities and increased pressures will be further transferred to combustor, where we will be having heat addition through chemical reaction. So here we will be injecting fuel and we will be burning these fuels, so that there will be increase in heat and temperature. This process will be taken by maintaining constant pressure. Then we will be moving further to turbines. Then these turbines runs the compressor. Because of the rotation of turbines, even a single stage turbine can rotate multiple stages of compressors. Okay, then we will be moving to nozzles, or free turbines. So with the help of these nozzles, we will be letting the gases to move out with higher amount of velocities. This is how the operation of gas turbine will be taking place. Then if we move on to the advantages and disadvantages, let us discuss about advantages. These provide a greater power to weight ratio compared to reciprocating engines. In reciprocating engines, will be generated with a lesser amount of thrust power when compared to this gas generator. So then these are small than reciprocating engines, counterparts of the same power. So here we'll be having reciprocating engines are somewhat complicated. We'll need to have there will be much moving parts will be there, much larger amount of moving parts. Even one part damages, it will cost much more. So here there will not be any problem like that. And lower emission levels, so here lower carbon emission levels will be seen in this gas generators. So if we move with disadvantages, these are expensive. High speed and high operation temperatures are needed. So for that purpose, in order to design these high speeds, we need to spend much amount of money. Then we'll be designing and manufacturing gas turbines is a tough problem from both the engineering and material standards. So this has to sustain a temperature of temperatures of a maximum of 3000 kelvins temperature it has to sustain. So it's somewhat difficult to select the materials. Even if we select the materials, those will be of very costly. Then tend to use more fuel when they are idling, right? When we are going to move them to move on the ground conditions, we need to use more amount of fuel than compared to the piston engines. Then they prefer a constant rather than a fluctuating load, right? Constant amount of load has to be given to it. And then if we go with emission in gas turbines, comparison of CO2 emissions from various power generation plants, if we compare with it, then we will be having lesser amount of carbon emissions when compared to other sorts of coal, oil, gas, GTCC, and these things will be having less amount of fuel emission. Gas turbine CC and gas turbine CHP will be providing you lesser amount of carbon emissions when compared to coal, oil and gas. Okay, then we'll be having lower emission compared to all conventional methods except nuclear. Okay, the only the thing which can replace gas turbines is nuclear propulsion, but that is much expensive and much complicated in designing. So we'll be going with gas turbine engines, and the regulations require further reduction in emission levels. Okay. And then what is need for future gas turbines? So first thing is power generation, fuel economy, low emission and alternative fuels. Next, this will be used for military aircrafts in order to generate high thrust and low weight. Then if we go with the commercial aircrafts, then we'll be having low emissions, high thrust, low weight and fuel economy. These are the future needs for the types of aircrafts and for the power generation things. Half the size, and we need to design half the size and twice the thrust. This is what our future motto is, and double the size of the aircraft and double the distance travel with 50% of NOx. With this, we'll wind up the session. Thank you.